Добрый день. Наконец, вечер и утро для тех, кто находится на другой стороне Земли. Я Николай Михайловский, генеральный директор компании НТР и немножко сменный ведущий этих вебинаров, которые мы вместе с Высшей IT-школой Томского государственного университета проводим. И сегодня я рад приветствовать у нас Юлию Киселёву из Microsoft Research Redmond, Вашингтон. Правильно? Вы в Редмонде?
В Редмонде.
В Белвью, небось, нет?
Нет, в Сиэтле.
Ну ладно. В Редмонде, который будет рассказывать про соревнования, которые сейчас фактически проходят в рамках ведущей конференции Near IPS 2021. Юлия, передаю вам слово. Вопрос, как вам удобно отвечать на вопросы? Прерываться, сделать 1-2 перерыва или в конце?
Лучше, если вопрос поступает, сразу на него ответить. Можно прерваться, чтобы было понятно аудитории, чтобы мы не потеряли свое положение.
Хорошо. Итак, коллеги, у нас есть Q&A, у нас есть чат, можно туда писать вопросы, я буду помогать Юлии их разбирать. Ну все, я передаю бразды и слово.
Спасибо большое, очень рада была быть здесь. Для презентации я перейду на английский, потому что, к сожалению, уже очень давно не говорила по-русски на рабочие темы. Вот очень долго процессила, что такое функции потерь даже. Yeah, let me switch to English, but like any other discussion we can keep in Russian. I will try to do my best. So I'm happy to be here and present and share with you the competition which is currently ongoing in Europe. So the which would be live till November 30, and the competition called we call it IGLU, so interactive, which stands for Interactive Grounded Language Understanding in Collaborative Environment. And I'm happy to present here also that it's like actually the huge collaboration among different institutions, which is the Microsoft, University of Amsterdam, and Moscow Institute of Physics and Technology, and Facebook AI. So that's just to attribute that this competition was possible only because of the great collaboration among all these great people. So and also we want to thank our sponsors, which are actually the competition is having a prize. We will talk about that later. So I want to really thank our sponsors for having the prize, having actually the grants for the compute in case you need the GPU machine. So, but let's go a little bit closer to what this competition is about. So, so what's the motivation behind this work? We noticed that there's a lot of advances happened in space of natural language processing, and some of the natural language tasks actually I wouldn't say they're solved, but we are close to kind of actually proposing a quite nice and grounded solution. And another area which is very attractive at the moment and is reinforcement learning. So in these two areas, actually, people don't really talk to each other that much. However, we think that there's a lot of interactions, possible interactions there. So, and I would say that the maybe main core subject which we tackle in this competition, which is actually just starting to grow, is more like embodied agents, where the agents where agents are able to interact with humans. And in our case, we're trying to approach the problem as follows. So as humans, we actually acquire our skills not only from excessive amount of demonstrations and excessive amount of trial and errors, but actually we acquire our knowledge through language. So you can give us instructions and humans are able to process those instructions. So, and that's basically the idea behind the challenge. So to develop AI agents that are capable of engaging in dialogue with humans to assist them in completing the real world collaborative tasks. And yes, another main thing which we wanted to approach in this competition is bringing together people who are studying natural language processing and reinforcement learning. We're actually not the first, so like people actually working on has started working on that quite a lot recently. So, and let's go over like what is a collaborative environment. So we have seen a lot of progress in AI beating the humans recently, and it was impressive. But maybe that's not the only end goal for the research. We actually want to create a collaborative environment where AI and the humans can collaborate to create something better together. So, and in our work, we consider a collaborative environment from two perspectives. We were trying to understand how to teach, how to create the instructions in a natural language that the agents can understand those, and what's the best possible way. And another one is how to learn. So basically, the research questions stands here for basically building the agents which are able to acquire the language. And let's also remember that we have this word grounded. What does it mean, grounded language understanding? So that languages also understand, the agent is able to understand it in a context. And in our case, we will look at it closer. It's a context of the game. That's Minecraft game. So to summarize, so we try to tackle two research questions: how to teach, and that's our architect task is how to learn. So, and in this case, how to learn can be split into two types of learning, as we call it, more like a silent builder, or like we're now a little bit switching from agent, which is much more general word, to builder. That's the builder who is basically taking the instructions and needs to produce some actions, and interactive builder. In this case, it's getting closer and closer as a human. So basically, we don't only process information, but if information is unclear, we ask questions. So that's what we call the interactive. And how to teach, here we switch from teacher to architect. It's just much more common terminology in the area. And here, like we again want to learn how to give instructions. And in this case, that's important because tasks can be complex. And as a humans, we are actually able to split this task into subtasks and kind of being able to do to give our instruction in sequential manner. And if it's still maybe not clear, here I try to provide an example. So what kind of environment we're talking about? So we're talking about Minecraft environment. It's a little bit, not a little bit, but quite limited Minecraft environment on purpose, because the task is already too complex to also deal with all kind of unnecessary, in this situation, or running water or like other staging things. So you could think about that more as a grid world. And the task is the following. You have two players, an architect who's given the instructions, and a builder who needs to follow the instructions. So architect has a task. You can see here, like you have a target structure. So, and he needs to explain in a natural language, as you can see here on the right side of the chat history. And he could see, the architect can see what builder is doing, and then provide either next instruction, or he can also ask, the builder can ask questions if something is unclear. Again, because when we interact among each other as humans, it's totally normal to ask those questions, and we don't expect humans to kind of give us perfect instructions. However, like the disposition is that most of the time when we interact with AI system, we kind of assumes that they don't do mistakes. They do that all the time, but it's more about being able to recover from those mistakes. So, and in our competition, we have two tasks, basically, how to teach and how to learn. So it's architect task and a builder task, so we call it. So we're actually quite lucky that there's a regional data set which were collected actually in Minecraft by our colleague from University of Chicago, and here you can see the reference to the original paper, which we actually can use as a baseline, and a data set we could use as a warm-up data set. So to just also go over that once again. So architect task, he's given the target structure, he generates step-by-step instructions for the builder. And for silent builder, he's just following the conversation, trying to build a structure. And the interactive builder is given architect instructions. He's building the structure, but possibly can also ask the clarifying question. But just to say it up front, so in this year, we mainly focus on a silent builder task, just because it's a little bit easier than the interactive builder task. But the data we're collecting at the moment actually can be used for both. So, and the pipeline is the following. So now we have at the stage 1, the competition is ongoing. So where the evaluation is happening at the basically offline. So you can register. There's 2 tasks, 2 separate submission websites, and 2 separate leaderboards, and download the training data. And for builder task, I will also talk more. We provide for you the training environment too. And there's the offline metrics which we use at the moment to pick the best solutions. And after the competition is done for the stage 1, so as I said, it's going to be just before NeurIPS, November 30. So we are planning to do the human in the loop evaluation for the best performance solutions if they're reasonable. So, and that would be actually quite challenging. And that's one of the first times where we want to put the agent in front of the humans. So basically the architect would be related with a human, so where the builder would be played by human and architect would be played by model, and vice versa, where the builder would be for the build at the place of builder we have the solution, and the humans is given the instructions. So I think it's in general, like my perspective is a way to go. So we have a good understanding on how this solutions actually work well or not work well with the humans. And I will talk a little bit more about our proposal about what type of evaluation, because if you just go and read the literature, there's a lot of still debates about how those things needs to be evaluated, especially, for example, we could look at that in a dialogue community. So we have some standard automatic evaluation, but there's still a lot of misconception about what this automatic evaluation actually show us, and if it's actually even leading the solution to the right direction in any case. So data collection. That was actually quite a challenging part of the our competition, to be able to collect the data. So as I said, we were very lucky. So there was warm-up data set which we could use, which was collected in the lab settings in University of Chicago. So basically they had ability, that was before pandemic also, to invite 2 students or just anyone who wants to play, and they can put them in a neighboring room, and they can interact with each other. The data was collected if it's important for some of these people who actually core-based reinforcement learning, but they use Malmo. Malmo is a very nice and kind of my important milestones for combining so kind of bringing RL to Minecraft environment. And there you can deploy your agents and see how they interact with Minecraft environment. So this this library was extended, and give us ability to collect data with 2 humans. But obviously, and we actually tried, that's not really possible in a scale. Like if you cannot invite grad students to the lab to play with each other, like how would you even collect the data? So like this another complexity was most of this task is like, again, how to collect the data. Naturally we look at the crowdsourcing platforms, but there, how would you have 2 humans to be online at the same time? So it's also quite challenging. So how we implemented it, we actually implemented with Mechanical Turk. We tweak it a little bit from the following perspective. So we don't require at the moment that 2 players will be online all the time. Rather, we convert this task into the sequential. So there's a mTurk worker who's logged in, and he's assigned the architect role. And he can have in his interface, he can see the target structure, and he needs to give the first instruction. Then we have the next, based on this instruction, we generate automatically the next hit, which is the task in the space of mTurk. And that looks like a builder. And here we have the Voxel World. I must attribute all the help which was provided by FAIR for developing the sort of Voxel World is like this limited Minecraft, which can be rendered in a browser. So we actually can collect the data from all over the world. Like it doesn't really matter like if you do have installed Minecraft or you don't. And that was technically quite challenging, especially for the challenge like this, competition like that. So, and another thing is that like we able to bring this data back to Minecraft, and be able to bring this data back to Malmo. So that's important that for reinforcement learning in terms of action space. So, and this way we have collected the data set. So here you can, for example, see the visualization of some how the building is ongoing. So it's based on real data. And as I said, as a warming up data set, we use this data set from Chicago University collected earlier. And in our case, basically each time the builder is logged in, so he can see the instruction, and if the instruction is not clear, he indicates that and asks a clarifying question. And if it's clear, he just asks and builds. So it's a sort of in the end, the structure which we will, and at some point the builder would should indicate the structure is complete. And what's nice about this task is that, like in terms of objective evaluation, is in a sense is the structure is either the same as expected or it's not. And this is a very objective way of evaluating how good or how bad was interaction. And here you can see the visualization of the data set. So you can see that how the, in this case, builder is trying to build a structure which is he instruct to do. And so like it comes along with a dialogue. So in this case, architects keep giving the instruction in natural language, and looks like instructions are clear to the builder, so he's not trying to ask a clarifying question. Otherwise, they would do. I would say that at the moment, about 8% of all the like utterances we have in those dialogues actually the clarifying questions. So which is expected. So because we instruct the architects nicely to give a sort of nice instruction. So that's just a visualization to kind of make it really clear that the task I explained it well. So if you still have any questions, please put it in the chat. So, and architect task, so again, we have this type of structures. That's important to also, like, you probably can ask me, like, what kind of structures are there? So, like, we have about 150 different structures, and they can be of different complexity. So, and we actually have the labels for that. And complexity can be measured in terms of number of blocks needs to be used to build a structure, on different number of colors, which the builder needs to do, and maybe some also visual complexity. But you could see that they're not that easy. So, like, and if you start actually playing this game as a human with another human, it's not always that easy to explain what you need to do. But this is actually quite nice because, like, imagine you want to build a house and you want to explain it to the robot. Is also not that easy. So, and dialogue information, we have the time step, chat history, builder position, builder block inventory, locations of the block, and screenshots. So basically, again, that's what we sort of think that why we call it grounded, that is not only language, but it's actually like comes with a visual representation. Okay, so and as a baselines, we use the method which was developed in paper which I referenced earlier. So, and it's actually simple encoder decoder structure of with two inputs, which is a text and those images. So, and here you could see the evaluation. So you can see that, so as I said, so most of the time the dialogues are still evaluated with a blue score, which was designed for the actually evaluating the machine translations. But you can see that actually the task is quite, if blue score is not that intuitive, so that you could see that based on the precision, that the task is not easy. So in this case, basically, you're trying to predict the utterance generated by human, and just to compare those to one that you predicted. So, and for the offline evaluation, so we have we will follow the blue score, not because we believe in it, but it's just a standard way. And as I said, so like for the future, we will have the human in the loop evaluation. So where we will pair builder with builder would be human with a trained agent, and in this case, with still that's still ongoing discussion. How can we collect the evaluation as like language, how natural is the language, and instruction accuracy, and maybe something else. So here you can find the information about submission website. So it's submitted through the Codelab, and the information about prices. So for each task, we have a separate price stage in here. That's basically the same you would see for builders. So like we didn't discriminate among the tasks. And if you want to like see more about this, like you can just either see the website, or like we try to keep our Twitter also active. So, and the builder task. So the goal is here basically opposite, like the builder structure, which human is trying to instruct us, and builder is able to navigate, he's able to place a block and break the blocks. So, and actually the instructions can even be given to you. As I said, this was a collective effort. So sometimes maybe the previous builder did something wrong, and then the instruction would be not about the continuing building the structure, but rather like destroy what has been done wrong there. And as I said, we have more than 150 goals. In this case, like more than 150 structures. And here is like a little bit more also examples for you, like how it looks. It can go from this L-shaped structure in orange, you could see on bottom right, and to like quite a complex as like this heart. I think it's most the complex one. So, and how that's basically looks for like try to format as more as a machine learning, like more machine learning problems. So basically for the builder, so like we have the observation space. In this case, as I have showed you before, you could think about that as those visually wise about this as those videos. So, and we have different types of actions like we provided for you. It depends on how would you like to solve this task. Again, I don't want to go too deep into that because I'm not sure how many people actually work with that before, but like in case you have worked with that with Minecraft, so like we have this human level actions and actually changes of the environment. So we try to collect the data and convert it in different ways so that like anyone can play with that depending on your background. And so basically the main thing is here is that we provide the environment, which is dreamlike environment, which is able to take this RGB observations and the dialogues in natural language, and the ideas produce the next action. And again, here we're talking about the silent builder. However, for the future, we really want to design it as an interactive builder, where at each step, when the agent is generating the action, it's always should be designed, either you make an action like continue building, or again, in the case of uncertainties, you would ask the question. So, and actually, like we kind of position that as a raw task, reinforcement learning task. It's not necessarily reinforcement learning task. People tried, and I would say quite successfully try to solve it as a supervised learning task, where basically you try to predict your target. And if everyone is interested, there's a paper about that from ACL 2020. So based on the same data set. However, like we just think this is naturally can be a nice RL task. And just to make it clear what's the environment components are here. So we have a poll, we have inventory and agent position and a grid and a compass and the chat. That's the chat one here is exactly the dialogues. So it comes from dictionary called info. And as I said, we have different types of action spaces, the human-like movement, feet movement, and creative mode too. And you could find the environment on the GitHub, and it's like provided with quite a nice documentation too. So, and rewards for building. So we first of all like try to basically kind of reward the agent for the right moves, because in the end of the day, we either focus if the task is solved or not. So, and by solved, that means that we build the original structure. But we also try to see if the builders at least tries to kind of build the structure which is similar. Maybe it's kind of in a different position, maybe like it's a different angle that we expected, and just to try to introduce it in our evaluation signals. So, and as offline metrics, we use completion rate, success rate, and reward. And as a human evaluation, I think that would be even more challenging than for natural for the architect task, because architect task is still similar to dialogue systems, and dialogue systems are widely studied, and especially last three, maybe even 4, maybe 3 years. So there's a lot of research has been done where people try to see how the dialogue systems should be evaluated, and there's, I think we kind of closing it a little bit so that it becomes more conventional. But actually, how to evaluate the RL agents with the humans, that's totally Wild West at the moment. So obviously, we will look for some structure correctness, but also we can ask if the movements of the builder is sort of human-like, because RL is famous for like making a lot of unnecessary moves, which is not what you expect to. So, but I think it's also going to be experimental. We'll see also what kind of solutions we will get in the future. And as I said, so we have the same prices, and here you can find a link to the Codelab, which is a submission website, automated, and there you can download the starting kit to just start playing with the data, get environment, and all the other information you need to start solving the task. And I think that's question time, if any. I'm even ahead of time.
Okay, thank you, Julia. All right. Does anyone have any questions right now? I wonder while everybody's, пока все собираются с вопросами, вопрос такой: у вас же есть референсная имплементация какая-то и для архитектора, и для билдера?
Yes, да, у нас есть baseline для архитектора. Для архитектора baseline очень простая. Для этого мы адаптировали как раз baseline из статьи, на которую я ссылалась. Это простая структура, encoder-decoder структура, где на вход мы пытаемся, они пытаются взять representation из картинок и текста. То есть есть, и она достаточно, ну пока еще, у нас был сейчас один solution, который пытался побить этот baseline, на самом деле. Достаточно, казалось бы, когда я рассказывала всем, очень простой метод, но на самом деле его не так просто побить. То есть, мне кажется, это мое чистое видение, что здесь нам нужно будет очень много подумать о том именно, как правильно сделать репрезентацию, ну, то, что добавится на вход, как этот текст балансировать с картинкой. Потому что еще как бы, почему он grounded? Потому что здесь нет такого, что люди говорят, там, как обычно, например, в поиске или еще где-то, где, в принципе, вопрос, там, инструкция та же, она сама по себе самодостаточна, потому что она только в тексте. А тут можно сказать, поставь синий блок за голубым. И как бы как человек с этим соображает, он понимает, где находится голубой блок и пытается за ним ставить. А для машины достаточно тяжело соединить этих два спейса. Вот. И для rel task у нас тоже есть ребята как раз, вот ребята из MPTI были основные двигатели как бы вот этого rel части. Вот. Я больше по языку. И вот у нас есть, вы вот видите здесь на экране, у нас есть rel leap baselines и dreamer baselines. И вот я могу сказать, что в принципе они неплохо работают на данный момент. И что интересно, что мы заметили, что агент очень быстро научился убирать структуры. То есть разрушать он умеет очень хорошо. Строить еще, можно сказать, это как бы вопрос. Да, то есть все бейслайны у нас есть, и еще на данный момент мы постоянно выкладываем, то есть данные, о которых я рассказывала, мы их все еще собираем, потому что достаточно такой tedious процесс. И у нас нет для RL пока baseline based on demonstration, но мы как бы ее не планировали на самом деле. Вот.
Ну, собственно, вопрос мой был таков: может ли baseline архитектора использоваться в какой-то степени для оценки билдера, и в обратную сторону baseline билдера использоваться для оценки архитекторов submitted?
Наверное, на данный момент нет, потому что они не очень хорошо, ну, то есть как бы они работают, они настолько хорошо, чтобы мы могли на них положиться. То есть, ну, как бы это вся задача как раз их улучшить. И тогда иметь задачу, иметь solution, который можно, да, как бы попытаться показать людям и попытаться оценить, насколько они хорошо работают. На данный момент просто перформанс их не позволяет этого сделать.
Ну, есть же другая важная теоретическая задача, на самом деле, когда у нас есть две шумные системы, с помощью одной шумной системы оценить другую шумную систему.
Может быть, но мы не пробовали. Ну, сейчас на данный момент не планируем.
Окей. И второй связанный вопрос. Да, вот если, опять же, если у нас есть два бейзлайна, да, то теоретически они между собой могут общаться и что-то произвести. Да? Можно ли с помощью одного бейзлайна и неких сигналов дополнительных к тексту, который он подает, обучать эти вещи как end-to-end reinforcement learning систему?
На данный момент я думаю, что нет, и мы как бы не ставили себе такую задачу в данный момент. Мы ставили больше задачи именно интеграции языка и в action space, но на данный момент такого на самом деле, то есть мы не ожидаем, но в этом смысле как бы action space либо я больше думаю, что будет интеграция какого-то NLP-юнита с reinforcement learning. Я, если честно, не очень представляю, как Interactive Builder будет решен с помощью только reinforcement learning. Ну, может быть, кто-то на это кто-то сделает, не знаю. Но, отвечая на вопрос, они на данный момент, когда мы их, вот, например, baseline для билдера, мы пускаем его в environment, мы как бы не пытаемся двух билдеров пустить туда, потому что тогда будет уже какой-то multi-agent environment. Нам еще бы с одним справиться, на самом деле. То есть, по идее, как бы там более такая глобальная задача, это когда есть вот эти вот инструкции, и есть multi-agent environment, где каждый, может быть, отвечает за какие-то вещи. Возможно, с вопросами, это правда multi-agent такая система, где два агента кооперируются, и один отвечает за то, чтобы задавать уточняющие вопросы, а один пытается строить структуру. И тогда они как бы между собой решают, кто в данный момент должен действовать.
Ну, то, что вы говорите, да, оно имеет право на жизнь. Я же говорю про такую систему, где имеется архитект, имеется билдер, да, и они действуют как фактически энкодер и декодер. Да, и у нас имеется общий для них reward, который там состоит в том, насколько близко построена ими структура к исходной. Возможно, тогда они бы между собой энкодили и декодили не в человечий язык, а во что-то другое, более забавное.
Но на самом деле такие системы-то есть. То есть в итоге были такие попытки, чтобы два агента играли друг с другом. Я, если интересно, могу прислать ссылки. И в итоге тоже люди пытались что-то сделать на нормальном, естественном языке. Но в итоге они придумали свой язык, который намного быстрее, и как бы система обучается быстрее. Но мы-то как раз хотим, чтобы они понимали естественный язык. Вот. На самом деле работы такие были, и люди там пытались до этого делать. Вот только вот, к сожалению, опять же, это все сложилось к тому, что агенты стали общаться между собой на каком-то непонятном, то есть они как бы модифицировали тот же язык, то есть вот этот архитектор, видимо, придумал, как давать инструкции в самом оптимальном смысле этого слова. Но естественный язык – это не самая оптимальная вещь, но это то, как люди получают знания, так как мы между собой общаемся.
Ну, понятно, что между собой мы общаемся тем образом, которым для нас, белковых тел, это естественно. Вот. Возможно, с робототехническими агентами и общаться надо иначе. Ну да ладно. Вот у нас есть вопрос. Слава Чаунин спрашивает: насколько я знаю, Reinforcement Learning вознаграждает агента за выполнение верных действий. Как определяется награда в игре с большим количеством возможных действий, такой как Minecraft?
Ну, мы не решаем задачу Майнкрафта в данном случае. Ну, и еще раз, когда вы говорите о любой задаче reinforcement learning или пытаетесь какую-то задачу превратить в задачу reinforcement learning, то это, конечно, очень важно понять, какая у вас reward function. То есть это определяется обычно, есть разные способы, но когда мы говорим про такой стандартный, когда определяется это как раз тем человеком, который строит эту систему. То есть задачи Майнкрафта, я думаю, что их очень много. То есть целая линия competition, которая тоже вот можно на Newrep's веб-сайт зайти и посмотреть, сколько competition'ов на самом деле посвящено Майнкрафту. И там в зависимости от задачи, то есть есть вот mineral competition, который pure RL, то есть там нет никакого языка, ничего, просто пытаются построить агента, и там они майнят diamonds. Соответственно, как бы, если diamond мы получили, то и мы действуем в правильном направлении, то reward у нас повышается. Если этого не происходит, мы наказываем нашего агента. Соответственно, я думаю, вопрос в том, какую задачу вы поставите в Майнкрафте. И Майнкрафт, в принципе, бездонен в этом смысле. В нашем случае мы reward даем агенту, когда у нас есть completion rate, это когда игра закончилась, и мы построили или не построили структуру, которую обещали. И, соответственно, то, что я рассказывала, на каждом степе мы смотрим, если агент движется в правильном направлении. Мы даем ему reward. И я надеюсь, ответила на ваш вопрос. Еще раз, как бы, Майнкрафт — это такая среда, где можно в любую игру играть. Тогда вот, когда вот есть игра, вот, например, так более понятная, может быть, игра Go, там есть вполне понятный reward. Соответственно, поэтому reinforcement learning работает хорошо на задачах, где у нас есть вполне понятный reward. То есть, даже, да.
Да, Юлия, спасибо. Вот еще один вопрос от Владимира Смолина. Можно поподробнее рассказать, как агентам предоставляется от сервера информация о текущем состоянии постройки в виде общей картинки или раздельно о положении каждого блока?
Я, по-моему, здесь рассказывала, что у нас есть position, grid, inventory. То есть все, что есть в environment, мы предоставляем агенту для того, чтобы он дальше действовал.
Ну, фактически воксельная картина мира со всем, что там есть.
Да, абсолютно все. И на каждом timestamps у нас, соответственно, есть вот эта измененная структура environment. Вы можете думать, да, как Voxel World.
Окей, спасибо. Коллеги, пожалуйста, еще вопросы? Кажется, больше вопросов у нас нету. Юлия, большое спасибо за интересный рассказ. По крайней мере, мне очень было интересно. И всем до новых встреч.
Спасибо большое за приглашение. Если есть желание поучаствовать и поиграть с данными, кажется, слайд переполнен разными ссылками, которые можно посмотреть и посмотреть. И всегда можно прислать нам вопрос либо в Slack, либо в Twitter. Лучше в Slack.
Ну, на самом деле, там конкретно для нас в НТ вопрос о задачах в тексте и их интерпретации очень близок, хотя и не со стороны reinforcement learning, а со стороны natural language understanding. Вот. То есть это близкая нам тематика, но немножечко с другой стороны, без reinforcement learning, без Minecraft. Спасибо большое.
Спасибо.
До свидания.
Да. До свидания.